The Android stack is made up of 5 layers. At the bottom of the stack is the Linux kernel. The folks who developed Android decided not to, here's that phrase again, reinvent the wheel. Linux has been around for a long time and has been proven to be stable and secure. Linux has a great memory and process management scheme. In addition, Linux has a permission-based security model that Android takes advantage of. At this layer of the stack, you're going to find software that handles memory management, process management, and power management. This is also where drivers for components like the camera, Wi-Fi, there's camera, what do we have? I think we have Wi-Fi here. There's Wi-Fi driver, Bluetooth, audio, and more. This is where all those drivers are kept. Next up is the library layer. Most of the software here is written as native code in C or C++, and it's responsible for providing low-level functionality and computation-intensive services. Worth pointing out is the fact that Android rewrote libc. Let me highlight libc here. There you go. They rewrote libc so that it would be optimized for embedded use. This layer is also where libraries that do the heavy lifting for the platform are found. So for example, WebKit. There's WebKit. It provides a browser engine for CSS, JavaScript, DOM, AJAX. There's also the media framework. We'll pick that one out. It supports playing videos, working with standard codecs and file formats. What else do we have here? There's SQLite. SQLite's a lightweight relational transactional database. It's actually what stores a lot of the data that you might be using for things like contacts, for example. Well, there's also the Android runtime layer. The runtime is made up of 2 parts, the core libraries and the Dalvik virtual machine. Well, every application you run, whether that be the browser or the phone or the calendar or one of the third-party applications, any app that you run is going to be run in its own virtual machine. So the folks at Google built their own highly optimized version of the Java VM called the Dalvik VM, and it's optimized for runtime memory efficiency and also for CPU use. So it's all about we're running these programs on a phone potentially, something that has a battery on it, something that doesn't have unlimited memory, or maybe it has a slower processor on it. And so they couldn't just, or they chose not to just use the VM that normal Java applications would use on a desktop system, but rather rewrite the VM so that it works best for these devices that have batteries and that might have less RAM and less CPU than a desktop system would. We also have the core libraries here. Those things provide, well, think of these as like the Java SE libraries, but a kind of a light version of them, in that they're a subset of those libraries. They don't have things in there like AWT or Swing or the RMI packages. But what they do include is they add, I say it's a subset of SE, but it also adds more stuff on top. There's a whole bunch of packages, Android-specific packages, that are added in as well. And as I'm highlighting these things, there's also bullet points off to the left that highlight the same information. So for example, core libraries contain a subset of the Java API libraries plus some Android-specific packages, just like I said. Okay, the next layer up, we have the application framework. Well, this is, I guess I don't know if I mentioned just a moment ago, but the core libraries are written in Java. The Dalvik VM is, I think, in C. All these libraries would be C, C++ kind of stuff. Well, now once we make our way up into the application framework and up to applications, these are all Java. So this is the Java layers. So for example, here, the application framework, what does this give us? For among other things, it gives us a bridge so that we can access some of the lower level hardware APIs. So for example, we have the location manager. We use the location manager to access the GPS and get location information. We also have a telephony manager. So if we want to interact with the underlying radio interface layer, to talk to the phone, we can use the telephony manager. Also with this layer are components that provide core platform services. For example, we have the resource manager. There we go. The resource manager loads non-code resources like images and strings that you can use in your applications. We also have here the notification manager. And so if you want to add like a message into the notification bar, the status bar, we use the notification manager to do that. There's the activity manager. This handles the life cycle of your activities, the life cycle callbacks that are going to happen in your apps, and more. There's plenty that are in that application framework. At the highest level here, we have the application layer. The application layer. Whoops, let me try that again. Draw a box this time. There we go. And this is where both the Android provided apps as well as third-party apps live. So for example, contacts, phone, browser, those come with Android. But also if you wrote your own application and you installed it on an Android device, that would be at the application layer. Well, one of the coolest features in Android is that Google uses the same SDK to build their applications as developers use. So they aren't hiding APIs or giving special access to their apps. The SDK is open for everyone to use.